Welcome to lesson 4.2.3. In this lesson we will be solving simple trigonometric equations. Use special triangles or the unit circle to state the exact value of a. the cosine of 4 pi over 3, b. the sine of 1050 degrees, and c. the sine squared of negative pi over 6 minus 2 times the cosine of 240 degrees multiplied by the tangent of 3 pi over 4.
Okay, so to answer questions like this, I think the smartest thing that you can do is to reduce the angles down to their reference angles. That's probably going to be the simplest thing to do. You need to know how to do that anyway to answer a lot of the other questions that you're going to get in this course. So we might as well just apply that kind of thinking here. So let's take a quick look at this. Cosine of 4 pi over 3. Now, first thing I want to do here is figure out where that angle is. Okay, now dividing pi by 3, think about it like this. What I'm doing is I'm dividing the top half of the circle into thirds. So, and I always start here and I'm going to rotate out typically counterclockwise. So it'll be 1, 2, 3. Well, I've got 4 of those. So really what I've got here is got an angle that's going to come down here. It's got 4 of these thirds of pi. So that puts us in quadrant, okay, 3. Now I know that cosine is going to be negative in quadrant 3, so this is going to equal the negative cosine of the reference angle, and it's at this point here I think it's pretty clear to see that what we're talking about here in terms of a reference angle is pi over 3. And that's exactly how I've chopped up the circle here into, chopped up pi into thirds. Now I'm either going to go to my unit circle or I'm going to go to my special triangles, but I need to figure out what the cosine of pi over 3 is. I know that the answer is going to be negative because of the negative in front, and the cosine of pi over 3 turns out to be 1/2. So the cosine of 4 pi over 3 will be negative 1/2, and you can verify that on your calculator. Now let's take a quick look at the next one, sine of 1050 degrees. Same sort of thing here. I gotta break this angle down so I can see it more clearly. Now 1050 degrees, that actually involves going around the circle more than once. Okay, so here's going to be 360 degrees, 720 degrees, okay, and actually I don't think we get quite around, okay. Turns out, I believe, another full rotation would have put us at 1080, and so we're not quite there. 1050 is actually going to be 30 degrees short of the 1080 that I would have gotten for a third rotation there. And so now we end up in quadrant 4, okay, and I know that sine is going to be negative in quadrant 4. And it turns out, as I was saying here, we've got this additional 30 degrees here between the terminal arm and the x-axis, so that's going to act as our reference angle. And so now, we're going to just evaluate the negative sine of 30 degrees, which in this case is going to be negative, and the sine of 30 degrees is 1/2. So just like in the previous question, we got negative 1/2. Okay. Now let's look at C. And there's a lot more going on in this problem than in the previous two here. So we got a bit of work ahead of us here. We're going to have to figure this out. And notice that we're changing the units, the types of angles that we're working with here. Here this is radians, this one's in degrees. So we got to be a little fluid here. Okay, so first of all, let's take a quick look at negative pi over 6. So negative means I'm rotating clockwise. Pi over 6 means that I'm dividing pi, or the bottom half of the circle, into 6s, and actually only going 1. So it's going to leave us in quadrant 4. Okay, and I know that sine is going to be negative in quadrant 4, so this is going to be the same as the sine, the negative sine of, and in this case our reference angle would be pi over 6, and then the square applies to the whole thing, including the negative that popped out as a result of the angle being in the fourth quadrant. Now let's take a look here. 240 degrees. Well, okay, 240 degrees is going to be in the third quadrant. Okay, quadrant 3, because it's greater than 180, but not quite 270. The reference angle here will be 60 degrees. Okay, we're going to be 60 degrees beyond 180. And so this will be minus 2 times. Now, cosine is going to be negative in the third quadrant, and the reference angle is 60 degrees. So you got to be careful with negatives. I mean, if we're going to make a mistake anywhere, it's going to be on negatives. Okay, most of us, after you go through the course here, you're going to get the big ideas. You're going to get the big concepts here, but where they'll typically catch you on exams and whatnot will be goofy little things like making errors with the negative signs here. So there is a negative that comes out of that because that angle here, that 240, is in the third quadrant. Now let's take a look at 3 pi over 4. 3 pi over 4. Pi over 4 means we're dividing pi up into quarters, and 3 of them puts us into quadrant 2. Tangent is going to be negative in quadrant 2, so this will be the negative tangent of, and again, the way I've drawn that, because of how I'm thinking it through here, I'm dividing pi into quarters, my reference angle is going to be pi over 4. And it'll be negative pi over 4. There's another negative popping out of that. Okay, so we're really going to have to be careful with this once we evaluate it. So now, let's figure out what we got here. So this is going to be negative. Well, the sine of pi over 6 is going to be 1/2. That'll be squared here. Now I'm going to have the negative times a negative times a negative. So the result will be negative 2 times, okay, the cosine of 60, we already seen this before, it's 1/2. Okay, and that's whether you're going to the unit circle or special triangles, okay, but you should know that. Shouldn't have to use our calculators to figure that out. And then the tangent of pi over 4, okay, well the tangent of pi over 4 is just going to be 1. Okay? So now, negative 1/2 squared is going to be positive 1/4. Negative times negative will be positive. And then we're going to subtract, well, 2 times 1/2 is 1. So 1/4 minus 1, okay, is going to be negative 3/4. Now, that turned out to be a relatively nice value there. So I want to show you something that you can do on your calculator that might help with something like this. Now, it depends on the context of the question, but I want you to see this anyway. So what I'm going to do here is notice that most of my answers here are in radians. So I'm going to make sure my calculator is in radian mode. Okay, now I'll quit here. Now I'm going to evaluate this. I'm going to get the sine of negative pi divided by 6, close bracket. I got to put the square outside that. Okay, the calculator will understand that that means the whole thing squared. And now minus 2 times the cosine. Now, I'm going to put 240 here, but I have to tell the calculator that this 240 is a degree measure. So what I'll do here, and I'll show you this if you've never seen it before, press second apps to get into your angle menu. That's going to open up this menu right here. The very first option is the degree symbol. So I'll choose that. And what that'll do is that will tell the calculator, oh, that's a degree measure, not a radian measure. And then at the end here, we'll put the tangent of, what was it again? 3 pi over 4. So 3 pi divided by 4. Press enter. And you get negative 0.75, and again I can convert that into a fraction by pressing math. Very first option I have is convert to fraction, and there's my negative 3/4, just like we got going the long way. Now that doesn't always work because the ratios don't always work out to be nice like that. Oftentimes there's radicals in there because of the root 2 and the root 3s and stuff like that pop up here. But every once in a while it does work out to be a wonderful number, and that's just an option there.
Solve the following in the domain provided. A. Cosine of theta is equal to root 3 over 2 between negative pi and pi. And B. The cotangent of theta is equal to the square root of 3 between negative 360 degrees and positive 360 degrees.
All right. Well, this question here is pretty standard for the Math 30-1 course here. And it's not a question that you haven't ever seen before. In Math 20, you would have answered questions similar to this, although obviously not in radians. What really makes this uniquely Math 30 is the fact that we're going to really start to play with the domain right now. And so this is what we want to look at to start off with when you're solving these problems here. Where are the answers that I'm looking for? And what we're seeing from this, okay, is that the domain that we're interested in is a half rotation, okay, clockwise. There's my negative pi right there. Up to a half rotation counterclockwise, There's my positive pi. So the answer that I'm looking for is going to show up somewhere in here. Okay. Now what I do is I take a look at the question itself. And again, the first thing that I do, and I'm just trying to give you guys a pattern here that you can follow. First thing you want to look at is the domain. Next thing we're going to look at here specifically is the sign of the ratio. Don't even look at the ratio, the root 3 over 2, blah, blah, blah. It's not relevant right now. Notice that it's positive. That means, because it's cosine here, that the answer here is going to show up in either the first quadrant or the fourth quadrant here, because cosine is positive. So we are going to get a first quadrant angle, okay, or a fourth quadrant angle as a result. Okay, and now I can kind of see my two answers here. When the terminal arms that I draw here, where they intersect the domain that I've drawn, those are my solutions. So now the next thing I got to do here is figure out the reference angle. Okay, so now I need the reference angle. And as we've seen before, what I'll do is I will find that by taking the inverse cosine, okay, of the absolute value of the ratio. Now in this case it really didn't matter because it was a positive ratio anyway, but just as a habit to get into. So now I just got to think about the unit circle, think about angles here and what this means. Where is cosine root 3 over 2? Okay, well that's going to happen at 30 degrees, or, because we're in radians here, pi over 6. Okay, so pi over 6 is my reference angle. Now what I got to do is I got to put this in the proper quadrants. Now notice what this does though. Because my reference angle here is pi over 6, what I'm doing here is I'm taking pi and dividing it into sixths. And my reference angle is only that one fraction of the circle here. So to divide this into sixths, it's going to divide that quadrant into thirds, that quadrant into thirds. So now there's 1, 2, 3, 4, 5, 6 in pi, a half circle. But there's also 6 over here. So I divide that into thirds and this into thirds here, okay? So now let's follow that negative rotation first. Okay, my negative rotation, bearing in mind that this is my x-axis here, my negative rotation is going to come around this way. Here's that domain. Here's where I get my first angle. And that's going to correspond in the fourth quadrant. That's going to correspond to negative pi over 6. Okay, that's in this quadrant here, that's the first time I hit a terminal arm. That's my reference angle, pi over 6. And that's that becomes my rotation angle. When I look at my positive rotation, the positive half rotation, first time I hit that terminal arm, okay, is going to correspond to an angle of positive pi over 6. It's going to be in the first quadrant. Okay, and that'll be positive pi over 6. So those are the two angles that I'm looking for, okay, in this particular question. Now let's take a look at the next one, okay, part B. The question is the cotangent of theta is equal to root 3. Now notice, again, the very first thing I want to look at or pay attention to here is my domain, negative 360 to positive 360. Now what this is telling us, okay, whoops, sorry, my lead's gone, whoops, okay. What this is telling us is that my answer is going to be, first of all, in a negative full rotation out to a positive full rotation. Okay. So here's my negative 360, here's my positive 360. So I'm going to end up going around the circle twice. Now what I want to do here is identify the sign on that trig ratio here. And notice that sign is positive. Okay, cotangent. Well, cotangent is reciprocal of tangent, so I know that that's going to be true in the first quadrant and the third quadrant. So I'm going to draw that out here. So I'm going to get first quadrant angle, or 2 it looks like, and down here into the third quadrant, notice that the number of times that I intersect the domain, the lines that I've thrown for the domain here, 4 times. I'm assuming then there's going to be 4 solutions, 4 points of intersection. Therefore, I'm going to get 4 solutions. Good. All right, now I'm going to find my reference angle. So I'm going to go back now. We're going to look for the reference angle. Okay, I've got that the cotangent of theta is equal to root 3, but you know what? I don't really want to use that. So I'm going to reciprocate both sides to convert it to a trig function that I'm happier with. So the tangent of theta is supposed to be 1 over root 3. My reference angle will be the inverse tangent. Oops. And once again, although it's not necessary here, because it is positive, I am going to stick with the absolute value here. And when I find the absolute value, sorry, the inverse tangent of the absolute value of 1 over root 3, I am going to get 30 degrees. Okay, so there's my reference angle. Now what I got to do is I got to put that in the proper quadrants here, but I'm going to do it by following my rotation arms. So what I'll do here first of all, now notice I'm going to get a first quadrant angle and I'm going to get third quadrant angles. Let's start with the negative rotation. So I'm going to start over here and I'm going to rotate along here until I get to this terminal arm. Now the reference angle here is going to be 30, which leaves us with negative 150 right there in the third quadrant. So the first angle I find is the negative 150. Then what I'll do is I'll keep following that because there's another solution over here. I'm going to keep following this all the way around up to here. Now again, notice this is 30 degrees right here. So this has to be 360 less 30 degrees, or 330, but in the negative direction. So negative 330, and it is a first quadrant angle. Now that finishes that line for that part of the domain, okay, the negative part of the domain. Now I'm going to jump to the positive part of the domain. So I'll start here, just like I always should start on the x-axis with rotation angles, and I'll rotate out this way, positively, hit my terminal arm. This was 30 degrees, so that's an easy one. So my other first quadrant angle is going to be 30 degrees. And now I keep going along this positive rotation until I get into the third quadrant. Now bear in mind again, this was my 30 degrees, so 180 plus that 30 degrees is going to put me into the third quadrant, 210 degrees. Now I've got 4 different answers here. I could tell from the beginning up here that I was going to get 4 different answers. This has got to be it. I'm done. Those are the answers that I'm looking for.
Determine the value of theta to the nearest tenth that satisfies the following equations. A. Tangent of theta is equal to 0.371 between 0 and 2 pi. And B. The cosecant of theta is equal to negative 4.33 between negative 180 degrees and 360 degrees.
All right, now you're going to notice that this question is in many ways similar to the previous question here, except when we find the reference angle, then you're going to notice a fairly substantial difference here. And there is a reason why we do these ones later here. A question like this, you would have answered, not in radians obviously, but you would have answered this in degrees in Math 10, Math 20, you really wouldn't have thought much of it. It does become a little bit more of an issue when you're in Math 30. I'll explain that in just a second. So here we go. We're going to solve this equation right here. Again, just as I said before, we want to pay close attention to the domain. So what is this telling us here? Well, we're starting at 0 and we're going around to 2 pi. So actually this is a nice one. Okay, the domain that we're working in is just a positive forward rotation. That's good. That's exactly what we've been doing the last couple of years. Perfect. Now I look at the trig ratio. I notice that it's positive. Tangent is positive in quadrants 1 and 3. So I'm looking for a first quadrant angle and a third quadrant angle. And that's it. So I'm only going to get the 2 answers here. Okay, there's just those 2 solutions. Now what I want to do here is I want to get the reference angle. Okay, so my reference angle is going to be the inverse tangent of the absolute value, and again, it's not necessary here because it's positive, but I just want to get to that habit there, of the inverse tangent of 0.371. Now, here's the issue here. This is not a unit circle or special triangle ratio. So what do? And I have watched all sorts of students stumble on questions like this, where in Math 10 and Math 20 it wouldn't have stopped you. In Math 30 it stops you because you get so used to using the unit circle, because we push that as soon as a question pops up that it's not a unit circle or a special triangles question, students often are like, oh, what do I do? And the answer is you go to your calculator like you've always done. Okay, so now I'm just going to enter this in. The inverse tangent, so second tangent of 0.371. Now I'm in radians here, okay? I'm in radians, so that makes sense. My answer makes perfect sense. I wouldn't be expecting some larger answer here. Okay, so you can kind of gauge for yourself whether or not your answer makes sense. If you're getting an answer like, 30, 40 or whatever, okay, well, you're probably in degrees, but in this case here, we're supposed to be in radians. So my answer here is approximately 0.4. Okay, now the question tells me to round to the nearest tenth. I am going to leave that in my calculator though. I round it when I write it down, but I'm not going to round that. I'm going to leave that in the calculator, so I'm going to come back to that in just a second. So there's my reference angle. Now what I got to do is put it in the different quadrants here. Now in quadrant 1, okay, and I'm just using the subscript to help me out here. That's not necessary, but it gives me a little bit of structure here. Okay, in quadrant 1, I'm going to rotate up, but as soon as I hit the terminal arm, okay, that's the end of my angle, and that's also going to be the same as my reference angle here. So quadrant 1 is the nice one, and so this is going to be approximately 0.4 radians. In quadrant 3, okay, I'm going to rotate, follow that domain all the way around to here. Okay, this is my reference angle, so it's going to be pi plus that angle that I found. Now, so I'm going to go to my calculator here, and it'll be pi plus, just in case you haven't seen this before, that little ANS right there, that refers to the answer that I just evaluated here. So second negative sign pulls up the ANS, that's going to be this right here. In this way, I'm not using a rounded value. And so I will get 3.5 when you round that to the nearest tenth. Okay, so approximately 3.5 radians. So those are the two solutions that I'm looking for in this particular problem. Okay. Now let's move on to the next one. Cosecant of theta is equal to negative 4.33. But more importantly, to start off with, I want to look at that domain. And notice where I'm looking here. I'm going to a negative half rotation, negative 180 degrees. Whoops. Sorry, the lead just did something weird on me here. Up to positive 360, a positive full rotation. Okay, so that's kind of odd, but whatever. Now look at the sign here. Now cosecant is the reciprocal of sine, so it's going to be positive and negative in the same place as sine here. So I'm looking for where sine is negative. Sine is negative in quadrants 3 and 4, and there it is. That's why it looks like this. I'm going to get 4 solutions. Okay, I've got 2 third quadrant angles and 2 fourth quadrant angles. Okay, so that's good. So now, to find my reference angle, first thing I'm going to do is I'm going to get rid of the cosecant here. So I have cosecant of theta is equal to negative 4.33. I'm going to reciprocate both sides here to turn this into sine of theta is negative 1 over 4.33. Okay, now, to find my reference angle, I will take the inverse sine, and in this case, I really do want to have that absolute value there of negative 1 over 4.33. Okay. Now, that is not going to be a unit circle or special triangle ratio, so again, don't hesitate on this. We're just going to go right to the calculator. So that'll be the inverse sine of, and if you want, you can even plug the absolute value in there. Negative 1 divided by 4.33. Oops, sorry. 4.33, there we go. Close that. And, oh, I got 0.233. Now, that's really small. When I think about what I was looking here, negative 180 to 360, that should clue me in. Oh, that's right. I never changed from radians to degrees. Okay, now if I do that again, so press second enter to repeat that. If I press enter, there it is. That makes way more sense. Okay, now I'm going to keep that angle in there. And actually, you know what? Because I'm going to need this a couple of times, actually what I'm going to do is I'm going to store that answer. So store is the button right above on here. Store, I'm going to store that in the X variable, press enter. Now every time I press X, I'm going to get this. The reason why I'm going to do that is because I am going to come back and use this angle more than just, once or twice. I've got 4 angles I got to find here. So now, I know my reference angle is approximately what did I say? What was it there? Negative 13.4, or sorry, 13.4 degrees to the nearest tenth. So now we just need to take that reference angle and put it into the proper quadrants. So remember the two quadrants that we're working in, quadrants 3 and 4. So we're going to get third quadrant angles and fourth quadrant angles. Now what we'll do here is we'll focus on the negative rotation here first. So now if we come down here into the fourth quadrant, okay, first angle we're going to bump into is going to be negative 13.4 degrees. Okay, now we keep going along here until we get to the third quadrant, and now we got to figure out, well, what this angle is here. Well, remember, this is your 13.4 degrees. Now, except we don't want to round, but I've stored that angle in X. Remember, if I press X now, there's my 13.4 here. So what we'll do here is, this is going to be 180 subtract that reference angle. So we're looking at 166.6 degrees. Now, granted, we're still along that negative rotation, so it's going to be negative 166.6 degrees. Now, we're done with the negative part of our domain. Now we're going to jump to our positive part, and we're going to rotate around here, and we don't get to a terminal arm until we're in the third quadrant. So that angle is going to be 180 plus our reference angle. And so this will become 193.4 degrees. And that'll be in the third quadrant there. So, whoops, you have to be able to see that. 193.4 degrees. And then into our fourth quadrant will be 360 minus that reference angle X. So 346.6. So 346.6 degrees. And there we go. Those are the four angles corresponding to those 4 points of intersection that we saw after drawing the terminal arms and our lines for the domain. There we go.